This is video 4.1.2, standard form. With a TI-83 graphing calculator. All right, so here's the equation that we are going to graph. Okay, this is a child of the parent graph that we graphed on in section 4.1.1 video. Okay, it's going to have the same shape, but it's going to be a transformation of that shape. All right, so here is back to our vocabulary that you got in your previous notes. A standard form of a quadratic function is y equals ax squared plus bx plus c. Okay? So, here I'm going to write that right underneath here. Y equals ax squared plus bx plus c. Okay? So the first thing that you need to know is to be able to identify what are A, B, and C in standard form of a quadratic equation. All right, so A, B, and C stand for the coefficients of these different terms. So A is the coefficient of the x squared term, B is the coefficient of the x term, and C is what's called the constant term. That's the term that does not have an x. So in this problem, A equals 1. See, there's no number in front of x squared. We assume it to be a 1. B equals the number in front of x, which is -4. And C equals 7. All right, so in standard form, the first thing we have to do is we have to find the vertex. Okay, so we're looking at this line right here in your notes. The x-coordinate of the vertex is x equals -b over 2a. That formula is very important. We use that a lot. Let me write that down. X equals -b over 2a. Okay. I am going to plug this a and b into this equation. So I have negative. Now b is -4. So I have -4 over 2 times a, which is 1. And I want to simplify that. Put it in simplest form. Negative becomes a positive. So I've got a 4 on the top, and 2 times 1 is 2. And 4 divided by 2 is 2. Okay? So this is, what is this? This is the x-coordinate of the vertex. All right, which again was 2. All right, that's the most important point on your parabola. I'm going to put a 2 here in my x column. Okay. Now to find any y coordinate, I'm going to take the x and plug it into the equation. So here I have for my y coordinate, y equals 2 squared minus 4 times 2 plus 7. And 2 squared is 4. -4 times 2 is -8. Bring down to 7. And then 4 plus -8 is -4, plus 7 is 3. All right, so I have 1 point, and I have the most important point for the parabola. Let me plot that point. So I have 2. Use some graph paper for this, and you can take the graph into your notes. All right. Now, the next thing the axis of symmetry is a vertical line through the vertex. All right? So what I want to do right now is I am going to draw a dotted vertical line through that point. Okay? That is my axis of symmetry. So every other point on the parabola is going to have a reflection across that axis of symmetry. Now, down at the bottom here, the y-intercept is C. So the point 0, C is also a point on the parabola. That's really easy. C is 7. Okay? So the point 0, 7 is also a point on the parabola. Let's graph that one. And that point is 1, 2, 1, 2 away from the axis of symmetry. So its reflection is going to be 2 on the other side of the axis of symmetry. So 1, 2. All right. And what are the coordinates of that point? That point has coordinates 4, 7. The y coordinates of a point and its reflection are the same. All right. Now I'm going to require that you plot at least 5 points on your parabolas before you draw them, and that you show 5 points in a table. All right. So you're going to have to pick one more point and then graph its reflection. Okay. So I always want to pick a point close to the vertex. So I'm going to say, what number is close to 2? Okay, well, 1. 1 is close to 2. All right? Close to the vertex. All right? Pick a number close to the vertex to plug in. And then again, I'm going to plug that into this equation. So I have, y equals 1 squared minus 4 times 1 plus 7. Negative 3 plus 7 is 4. So y is 4. Okay, let's plot that point. I have 1, 4. Okay, and then the reflection of that point across the axis of symmetry, well, that's 1 away from the axis of symmetry. And so if I plot a point on the other side of the axis of symmetry, I have its reflection. The coordinates of that point would be 3, 4. And then you can graph the parabola. All right, so this video ran a little bit long. I'm going to do the graphing calculator in a separate video.